solving FE exam problems for civil engineers. Today we will solve several problems in fluid mechanics and hydraulics. So question number one, it says Reynolds number is used to predict the flow regime. Which of the following indicates laminar flow? Now we know the classification of pipe flow is based on Reynolds number. So if Reynolds number is less than 2000, the flow is classified as a laminar flow. Between 2000 and 4000, the flow is classified as turbulent flow. 2000 and 4000 the flow is transition. And if Reynolds number is greater than 4000, the flow is turbulent. So here we look to the answers. So the answer is B, which is Reynolds number less than 2000. So this is the correct answer, B. The second question, the continuity equation in fluid mechanics is derived from which conservation principle? Now we know that the continuity equation is a mass balance. So the answer is B. It does not have to do with the conservation of momentum, and it does not have to do with the conservation of energy or angular momentum. So the correct answer is B. Now the third question, which device measures fluid velocity by converting kinetic energy into pressure energy? Here we are given several flow measurement devices in pipe flow, and we want to determine which of these converts kinetic energy into pressure energy. So the first one is the venturimeter, which is shown in the figure. Now the venturimeter is based on reducing the cross section here at this somewhere here. It is here now. So by constructing the cross section here, the flow velocity will increase because the cross section decreases and the pressure will drop. Now the pressure drop gives us, we can use Bernoulli equation to determine the flow. However, in the venturimeter, the pressure energy here at the section 1 here is converted into kinetic energy at section 2. So this is not the answer. Now the second option, the second choice is orifice plate, and the third choice is nozzle. So all the orifice plate, this is a schematic of the orifice plate, and this is the third one is a flow nozzle. So in the orifice plate and in the flow nozzle, and also in the venturimeter, the potential energy or the pressure energy at the first section is converted into kinetic energy. Now the device that converts kinetic energy into static energy is the pitot tube. Now this is the basis of the pitot tube. This is the pitot tube. Now in the pitot tube, there's a stagnation point here at this point. So the pressure becomes static, and that causes pressure head increase in this stagnation pipe. So by knowing delta H, the difference in the pressure, we can determine the velocity or the flow. So the answer is D. So the answer is D. Now, question number 4. Which of the following best describes turbulent flow? Flow with chaotic irregular fluctuation, flow with smooth orderly layers, flow dominated by viscous forces and the flow that occurs only in small diameter pipe. We know that laminar flow is a flow, fluid flows in layers where there is no mixing between the layers. Now, turbulent flow is a chaotic flow where mixing between layers occur. So the answer is A. Turbulent flow is a flow with chaotic, irregular fluctuations. Now, flow dominated by viscous forces, which is option C. This is laminar flow. Laminar flow is dominated by viscous forces. So it is not turbulent. So the turbulent flow is the flow with chaotic irregular fluctuations. Now the next question, what is the effect of increasing viscosity on the Reynolds number for a given flow? Now the Reynolds number, we see that the definition of the Reynolds number equals rho Vd over mu, where rho is the water density or the fluid density, V is the velocity, D is the pipe diameter, and mu is the viscosity. Now, by increasing mu, the dynamic viscosity, the Reynolds number will decrease. So, what is the effect of increasing viscosity? So, increasing viscosity will decrease Reynolds number. So, the answer is C. Next question. Now, the definition of a specific gravity. Now, the specific gravity is defined as the specific gravity of a substance divided by a specific gravity of water. Sg equals gamma of any substance divided by gamma water, and gamma equals rho g for any substance divided by rho g of water. So if we took the g from the numerator and the denominator, so specific gravity is rho of the substance divided by rho of the water. So the answer is A, the ratio of fluid density to the density of water. So the answer is A. The next question, which principle is used to derive the momentum equation for fluid flow? Now, the momentum, when we talk about the momentum equation in fluids, we talk about forces. We talk about balance of forces that act on a control volume. So the momentum equation says that the summation of external forces equals rate of change of momentum in a control volume. So which of these options A, B, C, and D is about forces, which is Newton's second law of motion? So momentum equation, when we talk about momentum equation, we apply Newton's second law of motion. It has nothing to do with Archimedes' principle, which is about buoyancy. It has nothing to do with Pascal's law, which is about pressure distribution in confined liquids, and it has nothing to do with the Bernoulli principle. So the answer is Newton's second law. Now the next question, the volumetric flow rate in a pipe is given by Q equals VA, where A is the cross-sectional area and V is the fluid velocity. Which of the following is the correct unit? Now, volumetric flow rate, it says volumetric flow rate. So it's volume per time. So the answer is C, which is meter cube per second. So this is the answer, meter cube per second. This is the volumetric flow rate. Now, in open channel, the next question, in open channel flow, which parameter is primarily used to describe the channel capacity to convey water? Now, in open channel velocity, this is the equation this is the Manis formula, the Manis equation for determining velocity in open channel. So this is the Mann's equation. V equals 1.49 over N. R to the 2/3 is to the 1/2. This is very well-known equation for hydraulic engineers and for civil engineering students, where V is the velocity, N is the roughness coefficient for the channel, R is the hydraulic radius, and S is the channel slope. So which of these parameters given Mann's roughness coefficient, Froude number has nothing to do with flow in open channel. It has to do with flow classification, and Reynolds number has to do with pipe flow, and Weber number is something different. So the answer is A, Mann's roughness coefficient. So this is the correct answer. A is the correct answer. Now the next question, which of the following best defines viscosity in fluid mechanics? Now viscosity, we know that viscosity is resistance of a fluid to flow or deformation. So here among the answers given here, the correct answer is A. Viscosity is resistance of a measure of a fluid's resistance to deformation at a given rate. So this is the definition of viscosity for fluids. So the correct answer is A. Now the next question. Which device is commonly used to measure the flow rate of fluids in open channel? So there are several devices. So here the choices are venturimeter, orifice plate, weir, and pitot tube. We've just seen that venturimeter, orifice, and pitot tube are used to measure flow in pipes, not in open channel. So in open channel, we use weirs to measure flow. So the correct answer is C. And this is an image of a weir. There are different types of weirs. So this is one type. So in open channel, we measure flow by the use or by implementation of weirs. So the next question. In venturimeter, we saw the venturimeter. This is again the image of a venturimeter. In venturimeter, the pressure drop observed at the throat is primarily due to what's the reason for the pressure drop at the throat here? This is the throat. What's the reason for pressure drop? Now, water is flowing in this pipe, or fluid is flowing in this pipe, and it has an initial area of A1. Now the area was reduced. Now if we apply the Bernoulli equation between section 1 here and section 2, which is conservation of energy, pressure, energy, and also potential energy and kinetic energy. So between sections 1 and section 2, what have changed is the velocity, is the kinetic energy. So the kinetic energy at section 2 has increased because the cross-sectional area has decreased, so the velocity has increased. So the kinetic energy has increased. So to substitute for this increase in the kinetic energy, pressure will drop. So whenever kinetic energy increases or velocity increases, the pressure will drop. So in a venturimeter, the pressure drop observed at the throat is primarily due to, now among the answers, the correct answer is B, acceleration of the fluid resulting in lower pressure. So which is increasing the velocity at section 2 because of the reduction in the cross-sectional area. So the correct answer is B. The next question. What is cavitation in the context of fluid mechanics? Now, in fluid mechanics, cavitation is defined or occurs when pressure drops or Yes, when the pressure drops below the vapor pressure of the fluid. Now, when evaporation occurs, in general, evaporation occurs for a fluid when the vapor pressure can overcome the atmospheric pressure or the pressure above it. Now, in fluids with the pressure in a conduit drops below the vapor pressure of the fluid, the water will boil. And this is known in the fluid as cavitation. So here we see at a construction, here in this drawing, we see that at the throat here, where the cross-section is reduced, the pressure will drop because velocity increases, and when it drops too low, evaporation, boiling of the fluid will occur, and this is known as cavitation. So among these options, a process where fluid is uniformly heated. No, this is not correct. The formation and collapse of vapor bubbles in a liquid due to local pressure drop. So this is the correct answer, which is B. So it has nothing to do with the acceleration of fluid in a narrowing channel. And it has nothing to do with the deposition of solid particles from a fluid. So the next question. The term hydraulic diameter is primarily used to. Now, hydraulic diameter, when we determine the friction factor, for example, for pipe flow, we usually use, most of the time, we use circular pipes. So it is based on the diameter. So for non-circular pipes, there's a definition of the hydraulic diameter, which is defined as hydraulic diameter is defined as 4A over P, where A is the cross-sectional area and P is the parameter. So the hydraulic diameter is defined to determine flow rate in circular pipes. This is not correct. Evaluate the friction factor in non-circular pipes. So this is the correct answer. Measure viscosity is not correct, and calculate the Reynolds number in compressible flow. This is not correct. So the correct answer is B, evaluate the friction factor in non-circular conduits. So this is the correct answer. So the next question, which assumption is not required for Bernoulli equation to be valid? Now, Bernoulli equation is applicable to inviscid incompressible steady flow. Inviscid incompressible steady flow. So the flow has to be incompressible. This is correct. Flow must be steady. This is correct. Flow must be horizontal is not correct. So this is the answer. Fluid must have negligible viscosity. This is also necessary. So the unnecessary condition is C. The fluid must flow horizontally. This is not necessary for Bernoulli equation. So this concludes this video. If you have any questions about any of the questions I just solved in this video, please send me a comment and I will get back to you. If you have any question that you want me to consider in the upcoming videos, please let me send it to me also in the comment, and I will do it in the next video. Thank you for following up my channel and for watching this video, and I look forward to seeing you in next videos.